So this is our first video on proof by induction. There are 4 types of proof by induction that we have to cover in Leaving Cert higher level maths: sums, divisibility, inequalities, and De Moivre's theorem. So in this video, I'm going to concentrate on sum proofs. We are going to go through the steps. So we perform the same steps in any type of proof by induction. De Moivre's theorem can actually be learned off, but for the other 3, you actually have to be able to work with the maths given to you. So step 1 is always prove true for the first integer in the question. So it's normally prove true for n equals 1. The second step is to assume true for n equals k. Step 3 is to prove true for n equals k plus 1, in other words, the next integer, and then we have a conclusion. All right, so we're going to look at a question now just to see how to apply these steps. And it's going to be the same 4 steps all the time. Step 1 is always prove true for n equals 1. Step 2 is always prove true for n equals k, or assume true for n equals k. Step 3 is always prove true for n equals k plus 1. And then step 4 is always going to be your conclusion. So this question we want to prove for all n is an element of the natural numbers, so we're looking to prove for all n is natural numbers that 1 plus 2 plus 3 plus ... plus n is equal to n over 2 by n plus 1. So this is our question. Step 1, we prove true for n equals 1. So we always start with the first available integer. Now in this case, there's no restriction on the natural numbers that we're looking at, so we always start with 1. If there was condition here where n is greater than or equal to 3, then you would have to start with your prove true for n equals 3. All right, so just be aware that that can happen sometimes. So in this one, we prove true for n equals 1. What we do is we substitute 1 into the left-hand side, 1 into the right-hand side, and for some proofs, we want to make the left-hand side equal the right-hand side. That's your goal. So if we look at the left-hand side is just 1. We're just adding the first natural number. If we look at the right-hand side, we're substituting n equals 1 into our formula. So that's 1 over 2 times by 1 plus 1. 1 plus 1 is 2. 2 times by a half is 1. So we have the left-hand side is 1, the right-hand side is 1. Because the left-hand side is equal to the right-hand side, it is therefore true for n equals 1. That's your first step. Step 2, we assume true for n equals k. Now you actually have to write these steps out as well when you're doing your proof by induction. A proof is a list of steps and you have to write each step out in full. So we assume true for n equals k. So that means that the first k natural numbers, so 1 plus 2 plus 3 plus all the way up to plus k, is going to equal k over 2 times by k plus 1. Next step is to prove true for n equals k plus 1. I'm going to rub out my first step so that I have enough room to do this. So step 3, prove true for n equals k plus 1. So remember, the idea is we want to make sure that the right-hand side is equal to the left-hand side. And for proof by induction, we have to use our step 2 in order to prove our step 3. For some proofs, when we're writing out the left-hand side, so we start off with 1 plus 2 plus 3 plus ... we don't go straight to k plus 1. We write out what we have in step k, and because k plus 1 is the next natural number, we add it on to the end. And that is going to equal, we're substituting k plus 1 into our formula here, so it's k plus 1 over 2 by k plus 1, so that's k plus 2. All right. So now we need to make the left-hand side equal the right-hand side. So we're going to work on this here. So we know from step 2 that the first k natural numbers is k over 2 by k plus 1. We are adding to that another k plus 1. All right. The reason I'm putting this in brackets now is we have a common bracket here to these two fractions. So we have k over 2 plus 1 times by k plus 1. All right. Now, we're nearly at what the right-hand side looks like, but we have to jig it around a little bit. So if we want a k plus 1 and a k plus 2 as our brackets, first thing we need to do is, so we have a k plus 1, that's that bracket sorted. So we need a k plus 2 and we need a fraction of 2. So the fact that we need the fraction of 2 out, we're going to factorize out the half out of here. And that's going to give us a half times by k is k plus 2. A half times by 2 is 1. And then we just tidy it up. So we have k plus 1 over 2 times by k plus 2. So now that we have the left-hand side equal to the right-hand side, so there's a few different ways of doing that. You can either multiply everything out in total and then factorize it down. You can do it as I've done it here. You know, there's, yeah, well, those are the two main methods of trying to figure this out, but just make sure that you concentrate on using an algebra method that you understand. The key thing is making sure that you get the left-hand side equal to the right-hand side. So now that we have left-hand side equals right-hand side, we need to write our conclusion. So first of all, we can say, therefore, it is true for n equals k plus 1. So in terms of our conclusion, so we've already proved, so if the statement is true for n equals 1, it's assumed true for n equals k, and true for n equals k plus 1. Therefore, true for all n is an element of the natural numbers. So basically you've proved that it's true for the first natural number. You've proved that it's true for the next natural number when assumed true for this natural number, and therefore it's true for all values of n. All right, so that is some proofs. The general gist of it will be the same. You just need to make sure that you follow your steps, and with sums, the key thing is left-hand side must equal right-hand side. So that is some proof by induction. All right, I'm going to give you some questions based on that, but they have occurred in the exam papers a good few times, so make sure that you look up those. Thank you.